what's up? I am Nisa.
Hi, my name is Arisha.
Hi, I'm Sarah.
Hola, hi, I'm Amiera.
Today I will explain to you what is application of differentiation. The differentiation is the subfield of calculus and there are various applications of differentiation in the real world. Differentiation is a very important part of math as it is used in many scientific fields. Differentiation can be defined as the process of finding the derivative of function. Differentiation can be used as a tool to calculate or study the rate of change of the quantity with respect to the change with some other quantity. For example, coffee maker. In the process of making coffee, coffee is running from the conical filter into the cylinder coffee pot. What is related rate? In differential calculus, related rates problem involve finding a rate at which a quantity change by relating that quantity to the other quantities whose rate of change unknown. If two variables both vary respect to time have a relation between them, we can express the rate of change of one in terms of the other. We need to differentiate both sides with the respect to time. That is, we will be finding df over dt for some function of t. Step of solving the problem. First, sketch the problem. Second, identify constant and variable quantity. Third, establish relationship between quantities. 4. Differentiate with respect to time. The last one, number 5, evaluate at point and of interest.
Today is such a hot day, but I don't care. Because after so long during MCO, I should stay at home. But today, I can go out to take some fresh air. So, let's walk.
Wake up in your bedroom and there's nothing left to say. When I try to talk, you're always playing board games.
After too much work, I feel so exhausted and a bit thirsty. I think I should get some cold water to relieve my thirst. I'm so happy. Now I can drink it. Wow, it has a lot of cube ice. I was thinking about this ice. What if a block of ice in the shape of a cube originally having volume at 1000 cm per cube? It's melting in such a way that the length of each of its edge is decreasing at the rate of 2 cm per hour. At what rate is its surface area decreasing at the time its volume is 64 cm cube? Assume that the block of ice maintains its cubical shape. Sarah, can you help me to solve my problem?
Let me try to figure it out. So let me look into the question. A block of ice in the shape of a cube. So the shape is cube. I try to highlight. Originally having a volume 1000 cm cube. So the volume is 1000 cm cube. Is melting. So the keyword is melting. In such a way that the length of each of its edge is decreasing. Again, we have the word decreasing at the rate of 2 cm per hour. At what rate is its surface area decreasing? So the surface area decreasing at the time its volume is 64 cm cube. Assume that the block of ice maintains its cubical shape. So first, we have to remember that our block of ice in the shape of a cube. So let's say here is a cube. So let's say I try to assume that the edge is x. So it's x. So the cube is melting in such a way that the length of each of its edge is decreasing at the rate of 2 cm per hour. So since the edge is x, that's mean the dx over dt will be equal to negative 2 cm per hour. Why is negative 2? Because the word decreasing. at what rate is its surface area? So with surface area, dA over dt will be equal to, we have to find the dA over dt decreasing at the time its volume is 64 cm cube. So when the volume is 64 cm cube. So first step, we start from the equation which is dA over dt. dA over dt. So what I'm trying to do is I will separate I will separate into two different rhetoric. So here is dA and dt. So what we're going to substitute here. So I will refer into the information that I have. So I have is dx over dt. So that means here I should substitute dx, here dx. So in this case, dx over dt is negative 2. So now I just have to concentrate into this part. I try to find dA over dx. Differentiate A with respect to x. So differentiate A means is the area. So what the area for cube? So cube, area for the cube is 6x squared. So next I'm going to differentiate dA over dx. So here 2 multiplied with 6, 12, 2 minus 1, 1, so x, 12x. So I will substitute into this rhetoric. So next step, dA over dt by referring here, to this part. Yes, by referring this part. So dA over dx here is 12x. So 12x multiply dx over dt will become negative 2. So 12x multiplied by negative 2 is negative 24x. So next, when volume equal to 64 cm cube, here, so volume equal to 64 cm cube. Now I'm going to substitute the value of x. What the value of x? So volume for the cube is x cube equal to 64. So x will be equal to third root of 64. Means that I try to move power of 3 here. So n of third root of 64 will be equal to 4. So finally, okay, therefore dA over dt negative 24 multiplied by x. So our x is 4. So negative 24 times 4 will be equal to minus 96. Since the area, so the unit is supposed to be cm squared per hour. So here the answer. Yay, I got the answer.
As the conclusion of application and differentiation, differentiation can help us to solve many types of real-world problems. The fields of the use of this calculus are wide, and it enters into many fields and are not limited to specific and for those who use it only. For example, graphic engineer use calculus to determine the difference and change of three-dimensional models and how it will change when exposed to the multiply condition. The other example, which is space. Space engineer often use calculus to help them when they planning to launch a probe to determine the variables of gravity and altitude for proportional of the probe with infinite challenge. I would like to mention two scope jobs that use calculus for their job, which is architecture and biology. Other job that use calculus in their routine or in their job, which is doctor, astronaut, chemist, biologist, and the others. Basically, calculus is used in every single thing in our routine in our daily life, and we all know it serves for 100 years. With all of this, that's all from us. Thank you.